Right, this lesson, we are looking into, so after that previous lesson, we'll work on trapezium rule. Today, we're going to learn how to solve differential equations. Now, this will be recalling, again, all your integration techniques again, when it comes to integration. So, quick recap again, integration is mainly about these skills in here. You also have a formula booklet, so before you consider any RTSP or LMP, if you don't know what it means, I'll go for it again, just a quick recap. But before all of these skills, you should remember to use a formula booklet when it comes to trigonometry functions, okay? Before, on top of any of these. So when you see trig function, the first thing you should look at is the formula booklet. The next thing is, when it comes to integration, there are these mnemonics you can help you remember all the skills. I call it RTSP. So R means reverse chain rule. So you should always consider reverse chain rule. T means trig identities. S means substitution. Usually a question will give you a substitution, what to let U to be. And then by parts. By part is about the isolate rule, is about the product. So when you have the integrate product, that's with in the different categories in the isolate rule, you can use by parts. By parts is also the formula. But in the reverse chain rule, when it comes to a fraction, you also have three options to consider. LMP. L stands for ln, you ln denominator, and negative power. For example, in here, if you have a fraction of 1 over x plus 2 squared, you consider x plus 2 to the power of minus 2. Then when you do reverse chain rule, you let y to be x plus 2 to the power of minus 1, because differential power of minus 1 will give you minus 2. So L means ln denominator. In here, you don't ln denominator because you got the negative power in here. So lnp, n is negative power, and p means partial fractions. When you see a fraction with more than one factor in the denominator, you can split it into partial fraction, then you do that. Most of the cases, you'll be told in part A to split into partial fraction first. Another hidden one about partial fraction is when it's a top-heavy fraction. Then if I ask you, let's say integrate x squared plus 1 over x plus 1. Okay, then a lot of students will probably struggle with this because you can't ln denominator. If you try let y to be ln x plus 1, you won't get x squared in numerator. If you try negative power, it won't work either because there's power of minus 1. So you have to let y to the power of 0, which doesn't make sense either. Therefore, you have to consider partial fraction. For this one, you have to do division first because it's top heavy. So you have to do x squared plus 1 divided by x plus 1, split it into different fraction first. Anyway, but that's in partial fraction. So just a quick recap on all the skill RTSP, LMP for fraction when it comes to reverse chain rule. Okay, so let's go back to today's lesson, which is about solving differential equation. So a differential equation is an equation that consists of a mix of variables and the derivatives. For example, x, y, and dy by dx. You have learned how to construct a differential equation in chapter 9.10 part 2. Remember all that proportional thing, where if you let dp by dt equals kp, that kind of stuff, you've learned how to construct it. And today's lesson is about learning the skill to solve it. We're not going to apply to those questions yet because that will be the next lesson on 11.11, which is about modeling. But today we're just focusing solely on the method on how to solve differential equation. So examples of differential equations are like this: 1 plus x squared dy by dx equals x times y, or dy by dx equals this. Because in these two equations, you can see there are x, there are y, there are dy by dx. So it's a mixture. It doesn't matter which side is a dy by dx on, or how they're laid out. Overall, x, y, dy by dx is all in one line. This is called a differential equation. To solve these equations means we want to get y in terms of x. So in other words, if you want to solve this, you would be looking to do y equal something. Okay, so that's what we call by solving. Solving means make y the subject. But in here, without dy by dx. So if you want to come out from an equation with dy by dx, obviously you want to undo dy by dx, which is called integration. So we'll come back to come to that in a bit. But the method we're going to use is called separation of variables. Now, separation of variables, you want to write down these few things in here. So usually you factorize it. Okay, so write down, you factorize it. You can only multiply or divide. Okay, so that's the usually two things that we do when it comes to separating variables. I'll show you how do we do that. Okay, example below. Find a general solution. To find a general solution, right, to dy by dx equals x, y plus y. Now, one thing you realize in here is if you try to find y, you can't quite make y a subject in here because there are two issues. One is you've got dy by dx, but two, if you want to integrate it, you also have y as well. So you can't quite integrate y when it's dx. So you can't do, let's say, 5y dx. It doesn't work. There is implicit differentiation where we differentiate and slap a dy by dx at the end, but it won't work on integration. So what do? We need to separate x and y, okay, one on each side. So now I'm going to show you some wrong working out that you might be considering, and I'll show you the correct working out and why it works. Now, what it won't work is, for example, okay, I want to separate x and y. That means I would put y on one side and x on the other side. So let's say we go on the wrong one. Let's say this is the wrong one, okay? Let's say we're trying to make subtract y on the right hand side, okay? This won't work because you've got y, and then let's say you try to divide by y. Then what's the problem? The problem is there's still a d, so that won't work, and that won't work either because you still got a dx. Okay, so these are the problems in here. So what do we do? Well, what we need to do is follow the two steps in here, usually factorize or multiply and divide. So this comes by experience. As you do more questions, you get more confident with it. Okay, so the correct one is, okay, when you do dy by dx equal, we factorize the y. And then what? Now, and then we're going to do something like a cross multiply, cross divide if you want to. So the y, I'll explain first of all, the y has to go on the left side, okay? And the x has to go on the right, dx has to go on the right side. So let's focus on the y first. If I want to make a y to the left-hand side, I'll need to divide. If I want to make a dx to the right-hand side, I need to do times. So when I divide the y left-hand side, it becomes 1 over y dy equal, on the right side, when I multiply dx, it becomes x plus 1 dx. But then this looks a bit weird, okay? So why is it weird? Because we've got dx and a dy. But usually when it comes to dx and dy, there has to be an integral in the front. Okay, imagine eating a burger with a bun on top, just a bun on the bottom. It'll be, you know, what you're eating is just a dish or, I don't know, whatever you call it. So you need to put an integral sign in there, okay, in the front on both of them. Okay. Okay, so then, so this step is called separation of variables. We factorize it if we have to, and then we separate the y on the left-hand side, and then the x, everything on the right-hand side, and then put an integral sign. This is what we call separation of variables. I'll explain it again. What do we do here? We want the y left-hand side, so we divide. Okay, we're not going to add or subtract because you can see when I add or subtract, you can't really separate x and y properly. In the first one, if I bring the y left-hand side, there's y on the right-hand side. If I divide y across everything, you will see I've still got dx in here, which has to be on the right-hand side. So that won't work, plus and minus. Therefore, multiply and divide is the way. Next, the next step is just a divide. It's just the integration. So this step, what we've done in this step is called separation of variables. So we're separating variables. Is that we're separating the egg yolk and the egg white. Oh, have you heard? If you want a bit of a crunchiness in the egg fried rice, try to add some eggshell in there. I'm just kidding. So next one, 1 over y and dy by dx. In this one, next step, you want to integrate on both sides. Okay, integrate. So this is where you pull out all your integration techniques, okay, in your arsenal to integrate. Left-hand side, to integrate 1 over y, that's simple, it's ln(y). On the right-hand side, what about plus c? We'll just do plus c on one side. Because there's no reason to have 2 plus c's when the 2 constant just mean the different numbers, which could be combined. So therefore, ultimately, you just have to do plus c on one side. Integrate x plus 1 is actually just x squared over 2 plus x plus c. Okay. What else can you do in here? Well, now, this done with the integration, but next step is something you need to learn how to simplify, okay, how to rewrite. Now, if I want to make y a subject in here, I can put an e on both sides. So e to the power of ln(y) equals e to the power of x squared over 2 plus x plus c. Now, e and ln will cancel out. So y equal e to the power of x squared over 2 plus x. Now, on the right-hand side, e to the power of plus c in here, imagine you've got e to the power of 2 plus x. Well, actually, that's, you can split into e to the power of 2 times e to the power of x, can't you? So that's what we're doing here. So we can do times e to the power of c. Now, c is a constant. When you have e 2.718 to the power of a constant, it becomes just another constant. So we can let another variable, capital A we usually use, equals e to the power of c. So we can rewrite y equals to a e to the power of x squared over 2 plus x, which is a lot neater than the one you had in here. Okay, so there's a skill that is quite common that you have to know as well. You'll be thinking, why so extra? Well, you know, maths is this extra. When we can simplify things in a neater way, we do that. Okay, so yeah, this specifically works for y, lmy, and an e to the power of c. This happens quite often, so we'll come back to this. Okay. Next one. Okay. Oh, by the way, one more thing I have not explained is general solution. Why is it called a general solution? It's a general solution because we don't know the value of a. Okay. So let's say, e.g., let's say you've got, and here, y equal, let's say, 2x plus c. Now, y equals 2x plus c, we know it's a straight line, isn't it? This is called a general solution because we don't know what c value is. Okay, so this is called a general solution. This is called a general solution. So again, this is called general solution. So you can write in here, this is called general solution because we don't know the value of a. Okay, because we don't know the value of a. If we know the value of a, it's called a specific solution. So on the side in here, e.g., y equals 2x plus c is called general solution. If you know c, let's say you work out c is, let's say, 2x plus 5, then this is called a specific solution. Okay, all right, we'll come back to this. I think we will actually have one of these questions later on. So next, find general solution of this. So first thing, you can see x, y, dy by dx, they're all muddled up. So our first thing we need to do, first task is to separate egg white and the egg yolk, which is known as the separation of variables. So the first that we need to do is separate x and y's. So again, you should only multiply, divide in here. So what do you do? So I'll just rewrite a question in here just to show you. Okay. Now I'm going to use a highlighter to highlight things that should happen on the left side and something that should appear on the right side. So dy will keep on the left side. Okay, so y on the left side. Therefore, 10y will follow on the left side. The rest of them, x on the right, dx on the right, and 1 plus x squared on the right as well. You might ask, why 1? Because the 1 plus x squared is together in the bracket. So it makes sense to bring everything together rather than just expand the bracket and do it separately. Okay, so yeah, so you do want to move the 1 plus x squared together as a whole, like a Lego block, to the right-hand side. So first of all, okay, we're going to look at the left side. I'm going to show it in here. So this means the left-hand side. Okay, this means the left-hand side. So this means that should go into the right-hand side. Okay, so this should go to the left-hand side. And this should go to the right-hand side. So left-hand side, 10y. When you go left-hand side, means we're divide. So it'll be 1 over 10y dy. Because we divide. Okay, now whatever little steps you need to write down to help you understand what's going on in here, do write in here. Okay, y is 10y on the left hand side. Okay, why is it 1 over 10y? Where does 1 over 10y come from? Okay, you can explain yourself. 1 over 10y, okay, appears, okay, because we have to divide 10y, as 10y has to be a left hand side. Okay, these little things does help you to understand what's going on. And on the right hand side, x is there, so we're going to replace. We're going to keep it there. Dx, we're going to multiply right hand side, so for dx, 1 over x squared, we have to divide as well. Right, now then we can integrate and then put an integral sign. Right, I explain again. 10y shouldn't be difficult to understand because we just divide to the left hand side. Dx is denominator, so we multiply right hand side. 1 plus x squared is times, and times, there's hidden times in here. So if you move the right hand side, it means divide by 1 over 1 plus x squared. This is called separation of variables. Now we've separate everything nicely because the y is on the left hand side, the yolk, x squared, everything about x is on the right hand side. Next step, time to integrate separately. Now, how do we integrate 1 over 10y? Remember, first thing, when it comes to trigonometry, look at the formula booklet. 1 over 10y doesn't have anything, but cot y does. In the formula booklet, we know integral of cot y is ln sine y. So first thing, I'm going to change this into cot y, right? Because I know the formula booklet give me 1 over 10y cos y, the integral of cot y. Now, right hand side, what can we do on the x over x squared? So remember, reverse chain rule, we got LMP when it comes to fractions, the reverse chain rule. So RTSB, we're doing reverse chain rule and the LMP. First step, we're going to consider the ln denominator. So in here, what we can do is we can let y equals ln denominator, 1 plus x squared, to verify it. Let's try differentiate. Now, these steps have to be shown. You can show these steps, okay? These steps are not a sign of weakness. You're not trying to hide it from the examiner. You should instead, you should show it, okay? Like a medal, okay, of honor. So ln is 1 over differentiated, 1 over x squared, times differentiate inside is 2x. Compare with the original question, there's no 2, so I just have to balance the 2. That means it's a half of the y function, ln 1 plus x squared, and then we're plus c, all right? Now, we know at cot y, the integral of cot y, as I said, from the formula booklet, is ln sine y. So ln sine y equals a half ln 1 plus x squared plus c. Remember this, when with ln on the left-hand side, we can put an e underneath it. So ln sine y equals e to have a half ln 1 plus x squared plus c. Now, everything on top of the power of e. E and ln cancel out. Left-hand side is just sine y. On the right-hand side, this e and ln can't cancel out because of the power of a half. So we can do 2 things in here. 1, we can put a half into the power. Next, we can separate this plus c into it times e to the power of c. Same trick like last question. And then we let a to be e to the power of c. So left-hand side, sine y equal, now then ln and e can cancel out now. So 1 plus x squared to the power of a half times a. Okay, and therefore, if we inverse sine on the right side, we call it arc sine. So arc sine of a square root 1 plus x squared. Now, this is one of the standard results. We don't have to remember, but for higher level of maths, you will see this quite often. So yeah, so step by step again. To integrate this, we first separate the x and y, put the x on the right hand side. You can only times and divide. Remember, you don't add or subtract. Okay, try not to expand the bracket, because expanding brackets means you are breaking the egg. You're muddling with the egg white and the egg yolk, which you don't want to do that. If this, in a nice shell, pun intended, then keep in the shell. So times divide. So times, this one is times the opposite divide. This one is times the opposite, which is divide. Okay. And then it will take you some questions to get used to. And then you just have to integrate 1 by 1 separately, left hand side, right hand side, do a plus c. You see ln, so you put e on both sides underneath. And then we know this trick about this new trick that we've learned about plus c in the power of e. We separate it into times e to the power of c. We let a. Now, step by step, when you do the homework, do not try to go from this step to this step. Okay, do it step by step. Write this one times e to the power of c, let a to the power e to the power of c, and then do that. Okay. A lot of students, when they try to do too quick, they would have done it wrong. They would have put a plus a in here where it should be times. Okay, right. Next, this is not a specific solution. I've told you. These are called general solution. General solution because we don't know the value of a. If we do know the value of a, we call it particular solution or specific solution. Sometimes people call it. But a proper way I should have introduced is called particular solution. Okay, so when I mentioned here in the previous example here where I mentioned specific solution, you can also replace with the word particular solution. Okay, particular solution. So particular solution essentially is like finding out the value of a. We can substitute what we know as a boundary condition. I'll give you a quick example. Again, let's say y equals 2x plus c. Okay, normally how do you find c? Well, you will sub in the point. Let's say I know the point is 1, 0. Then you sub in 0 equals 2 times 1 plus c, so c equals 2. Now, this information is called the boundary condition, BC. Okay, I'll call it boundary condition. It's not I call it, sorry. I just call it BC, boundary condition. This extra information is called boundary condition. You will also use this in mechanics as well. When you integrate, let's say you want to find the acceleration, or find the velocity when you integrate the equation of acceleration. To find the plus c, you will sub in the values of v, etc., and time in there. So that's c. This is called the and then once you know c, then you can know y equal 2x plus 2. This is a general solution. Again, general solution. This is called the particular solution. I'm right. Sorry, particular solution. Sorry, I don't mean I can't write. I don't mean I can't. I mean I can't scribble correct properly. So this a proper scribble. This ugly scribble. Yeah. So particular solution. Okay. So to get from general solution to particular solution, we need what we call the boundary condition, which is extra information to help you work out the c value. Okay. You'll see in here in this question, find the general solution of this, and then that's the first part of the question. Second part is given that x equals 1, y equals 4. Now this is what we call the boundary condition. Okay, which is extra information which you can sub in to find the value of the unknown, the a or the c, depends. All right. Now, if you're confident to try to find a general solution, if you understood what's going on in the previous 2 examples in here to find general solution, I would suggest you, okay, try the first step to separate the x, y. Try to separate the x and y's. Okay. Pause the video, have a go to separate it. If you're unsure, just do it on a separate paper. You will check your answer. Okay. Then play the video once you've separated them. Okay. So I'll rewrite the question first of all. Okay, then I can decide what goes on the left, what goes on the right. Now there are options in here. There are options in here you can do. First of all, y. Oops, I'll use yellow for the y. dy on the left hand side. The y minus 2 must go on the left hand side. So I know this has to divide the left hand side. Okay. Next, what about the 3 minus 3 in front? Now some people will do the minus 3 as well. You can. Okay, I'm not going to stop you. You can do that. Okay, or you can keep the minus 3 because having a minus 3 on the left side or the right side does not really matter because the minus 3. Now, unlike the previous one, the 1 is unlike the previous one, where the 1 is inside the bracket, then you can't expand it, or you should move it together with x1 together with the 1 plus x squared. This minus 3 is a bit more flexible. You can either leave it there or divide on the left hand side because the minus 3 is not attached, it's not multiplied into the bracket. Okay. However, the minus 2 has to go together because the minus 2 is with the y together as a whole block of Lego, if you may think of that way. So yes, so this time maybe I can bring a minus 3 on the left hand side, okay? But you can leave it like this. The dx has to go on the right hand side. This has to go on the right hand side or stay the right side. So you got two options in here. One is where you move the minus 3 left hand side, so you divide everything. So it becomes 1 over minus 3 bracket y minus 2 dy equals 1 over 2x plus 1 bracket x plus 2 dx. That's option 1, or option 2, okay, which is you keep the minus 3. Now, either way is fine. So it'll be 1 over y minus 2 dy equals minus 3 over 2x plus 1 x plus 2 dx. Now, whichever one you feel like better to do with, okay, stick with that one. Personally, my preference will be the right side here because you do want constant in the top right denominator, which sometimes makes things easier to read. So maybe I'll use the right hand side here to help me work it out. If you have done this way, carry on. This way, what you do is you bring the minus 3 over and do the same thing, etc. So I'm going to leave it out for now. Okay, I'm just focusing on the right hand side. So on the right hand side, what do I do? Okay, to integrate left and right, to integrate left hand side, integrate a fraction, reverse chain rule, LMP. Remember, reverse chain rule, you can do LMP. In here, we should consider ln denominator. So ln y minus 2. If I try to differentiate this manually in my head, so it'll be 1 over y minus 2. Differentiate y is 1. It matches, so that works. Okay. Right hand side. Now, what can we do on the right hand side? Right hand side, we need partial fractions. That's a big Q in denominator because you can see 2x plus 1 and x plus 2, a product of 2 factors. So I'm going to leave it out like this for now because my next step which I'll need plenty of space to write, is the partial fractions. So I'll let you pause the video, okay, do the partial fractions in here. So it's minus 3 over 2x plus 1 bracket x plus 2 into partial fractions. So a over 2x plus 1 plus b over x plus 2. So let you pause the video, work out the value of a and b and split out, okay? If you're confident, you can just go on the way until the end to integrate as well on the left-hand side, right-hand side, simplify it. So I'll let you decide what you want to do. But first thing, if you're not too confident, just split into partial fraction and play the video whenever you're ready. So once you have split your partial fraction, you should get b is 1, a is minus 2. So therefore, I can rewrite now the right-hand side into ln y minus 2 equals the integral of minus 2 over 2x plus 1 plus 1 over x plus 2 dx. Then left-hand side is still ln y minus 2. The right-hand side, to integrate this, again, ln p, think about the integral, think about the ln denominator. Let me try this. If I try to do it in my head, differentiate this is 1 over 2x plus 1. I need to times it by 2. Compared to original, there's a minus, which I don't, so I'm going to put a minus in the front. Okay, that works. Next one, ln, this one is just ln x plus 2. Don't forget the beloved child, or forgotten child rather, plus c. Next, what can we do? Well, first of all, there are lots of ln in here, which is a good thing, because that means there's something I can simplify on the right-hand side. So I'll keep that ln the left-hand side the same. On the right-hand side, now there's a negative. If there's a negative, I can think of ln a minus ln b. Okay, so the minus sort of becomes the negative becomes the minus in the second term. So ln, the blue term, minus b. So it becomes ln a over b. And then plus c. They'll get e on both sides. Oops, so it should be the power. Next, e and ln cancel out in here. And then the right-hand side, I've asked you to write out separately first. So it will be e to the power of ln x plus 2 over 2x plus 1 times e to the power of c. Okay, now there's no c term in the power, that we can safely cancel the e and ln step by step. Y minus 2 equals then x plus 2 over 2x plus 1. The modular sign could go, and then we can times it by a. Oh, I forgot the step, haven't I? So I should let a equals e to the power of c, so it becomes a. X plus 2. So a times x plus 2. Sorry, let me write it properly again. So y equals a times x plus 2 over 2x plus 1. Okay, that's the, this question probably carried quite a lot of marks, just a general solution, part A. It probably 8 marks, probably 6 marks, 7 marks. I wouldn't be surprised. Let me make it part B. That's all part A. Part B, boundary condition, when x equals 1, y equals 4. So we can do that. We can happily do that. When x equals 1, y equals 4, we sub it in. So 4 minus 2 equals a times 1 plus 2 over 2 plus 1. So you should get a equals 2 here, a equals 2. Therefore, a particular solution is rewrite the equation of y, just like a y equals 2x plus c, you're rewriting equation y minus 2 equals a, which is now 2 times x plus 2 over 2x plus 1. And then you can plus the 2 on the right-hand side. Sorted. Okay, right, and that's the final answer. Is there any question for you to try? Yes, exam practice. Okay, pause the video, have a go at the question. 5 marks, because this one, separation variable, is not as difficult as the previous one. Pause the video. Okay, first of all, I'll ask you separate the variables first. When you're done with separating, then play the video, or you can go on and finish the whole thing if you're confident. Okay, pause the video, have a go. When you're ready, play. So here's the answer for separation. So first of all, this one, dy stay on the left side, so the dy will stay on the, the dy will stay on the left, the dy stay on the left side, and the y will stay on the left side. The dx on the right and cos squared x on the right. The 3 can just stay, you know. Why do you want to move if you don't have to move, right? So, yep, 3 over cos squared. So that's how you separate variables. Once you're done, okay, if you're happy with this, then you can go on and integrate on both sides and carry on work of the question, okay? And if you've done it, okay, your final answer after substitute everything as well, you should be half. The mark scheme says half y squared equals 3 tan x minus 1. But if you got y equal square root of 6 tan x minus 2 is also correct. Okay, so let you continue, play the video and see if you got this answer. If you haven't, if you couldn't, then I'll go through the workout with you. If you're done, and that's the end lesson. That's the end for you. Okay. Right. Again, pause the video. Carry on. Right in here, to integrate y, simple. It's y squared over 2. On the right side, now how do we integrate 3 over cos squared x? First of all, maybe I'll bring a 3 integral. Take the 3 out. Cos squared x. 1 over cos squared x. It's a fraction. However, when it comes to trigonometry, think about the formula booklet first. In a formula booklet, you do have the integral of sec squared, right? Sec squared, 1 over cos squared. Therefore, actually, I'll change it to sec squared x, which makes my life a lot easier just using the formula booklet. So y squared over 2 equals 3 times the integral of sec squared is just 10x, and then without plus c. So we just multiply 2 over, so it becomes 6 10x. Now, whether you times 2 or not with c, you don't have to, because times 2, when you multiply constant by 2, it's just another constant. So yeah, okay, so y squared equals 6 10x plus c. Next, we're going to sub in the boundary condition. Now, I do want to show you as well, just in case some of you might have done y squared equals 6 10x plus 2c. That's not a problem. That's not a problem. I'll show you how different, how they would work out differently, but achieve the same answer. When x equals pi over 4 and y equals 2, you sub in, so 2 squared, which is 4, equals 610 pi over 4 plus c. Then pi over 4 is 1, then c will be minus 2. So therefore, your answer will be y squared equals 610x minus 2, which is the same as my top in here. It's just there's no I didn't square root on the left hand side, on the right hand side. So that's the same thing. That's correct. Okay. Now, what about if you do the right hand side? Well, that's the same thing. You sub in x equal power 4 y equals 2 squared equals 610 pi over 4 plus 2c. So you would have in here, you have minus 2 equals 2c. So c equals minus 1. Therefore, in your final answer, you're going to rewrite your equation, your version. So y squared equals 610x plus 2c, 2 times minus 1, which is minus 2. So therefore, you achieve the same answer anyway. Okay, and that's the end of separation variables of solving differential equation. It's all about separating. Make sure all the y stay on one side and the x stay on the right side. Okay. So yeah, next lesson we are going to work on how to model with differential equation, which this skill becomes evident, becomes prominent. So that's the end of lesson. Thank you.